Imagine you need expert advice on something. Really niche, highly technical. Let's say the chemical architecture of a high-end perfume.
Right.
You ask your AI assistant, and it gives you an answer. It's immediate, it's confident, and a lot of the time, it's completely shallow.
It sounds right on the surface, but it's missing the core professional context. And that's the problem. I mean, it's this persistent fundamental challenge in specialized AI. How do you stop a generalist large language model from giving advice that seems competent but really isn't?
That exact failure mode, that's what we're tackling today. That moment the system crosses the line from being a helpful summarizer into a confident fabricator. We are going deep on the engineering methodology designed to solve this very problem, ActiveRAG, and this concept of epistemic anchor.
In our focus today, it's not really on the perfume advice itself, it's on the knowledge architecture behind it. We want to explain how you engineer that core foundation document, that source of truth that forces the AI to stop being a data aggregator and start becoming a domain specialist.
So this deep dive is really for the knowledge architects, the AI engineers, and frankly, anyone who's curious about how you build, structural integrity into AI.
Exactly.
Okay, let's unpack this. It has to start with the old way, right?
Yeah.
What exactly is going wrong with what we call passive RAG?
Well, with passive RAG, or traditional retrieval-augmented generation, the LLM is basically, it's just a passive receptor.
Like a high-speed librarian.
A very high-speed librarian, yes. It just retrieves the most keyword-relevant chunks of information from its data, and then it tries to synthesize them.
And I can see where that falls apart. When the topic is something like, why does this specific vintage oud note smell medicinal instead of smoky? Keywords.
Yeah.
They just won't get you there.
Not even close. When the concepts are that nuanced or highly technical, or worse, when they contradict what people think they know, that passivity leads straight to what we call model illusions.
Hallucinations.
Confident hallucinations, exactly. The model can match the keyword troop to hundreds of sources that use that word, but it has no way to actually verify if the structural components of that scent are really there.
So if passive raggy is the librarian who just grabs books that sound similar, then,
Yeah.
well, the next step has to be to make the LLM not passive. That's ActiveRAG.
Precisely. And ActiveRAG is a massive architectural transition. We define it as a proactive knowledge construction pipeline. It's built on constructivism theory.
Okay, so it's not just finding facts.
No, it's about the system actively building its own internal map of reality, the same way a human learns through experience and checking their work.
So the system goes from just compiling data to actually constructing a verified understanding. That's a huge leap for an AI.
It is. This active process has three main steps: retrieval, knowledge construction, and something called the cognitive nexus. But you can't construct anything without a solid base to build on.
A foundation.
You got it. It has to start with cognitive anchoring. You have to establish a fixed point of verified reality, a truth layer, before the model even starts to reason. And that fixed point is the epistemic anchoring document.
And this is where the story gets really interesting, especially for the engineers listening. Because to build this brand new truth layer, the team didn't turn to, cutting-edge deep learning. They looked backwards.
Way backwards.
To 1990s knowledge engineering.
It's a brilliant conceptual bridge. We realized that the broad, noisy internet fails completely when you need what's called tacit knowledge.
The unwritten rules.
The unwritten, intuitive rules that define real expertise. That stuff isn't on a blog post. It lives inside the heads of career professionals.
So to solve this futuristic AI problem, you reached back 30 years into computer science history, to the practice of expert elicitation. You literally had to pull that knowledge out, like data archaeology.
That is the perfect description, yeah. Instead of just scraping data, we focused on identifying a specific verifiable perfume expert 6. This was a carefully vetted group of historians, critics, and chemists with, real citable industry footprints. People like Victoria Belimprolova, who has formal raw material training, or Mark Benke, who comes at it from a molecular chemistry perspective.
So these were just influencers.
Yeah.
These are people whose expertise is rooted in verifiable analytical work.
And the method to get that knowledge out it was tough. It's called interrogative prompting. The goal wasn't just an interview. The goal was to convert their hidden intuition, how they judge a raw material, how they classify an aroma, into explicit, machine-readable rules and heuristics. It's like pulling teeth trying to get an expert to explain something they just know.
That sounds like a massive effort, but the payoff is clear. The content you get from that isn't just a reading list. It's an engineered set of rules. You call it static context augmentation.
And it fundamentally changes how the model operates.
How so?
It provides the AI with a cognitive roadmap. And this roadmap, this is the critical part, it replaces shallow note matching, where rows just gets paired with every other mention of rows, with professional evaluative logic.
I see. So the intelligence is built on engineered knowledge structures, not just random training data.
Exactly. Real criteria, not statistical noise.
So let's open up this blueprint. What does this epistemic anchoring document actually look like? I know it's structured into 4 critical sections.
It is. And the first section is all about grounding the system in reality. It's the expert roster. It establishes provenance and authority. This isn't a footnote, it's structural.
And it gets specific, right? You're not just saying perfume expert. You're saying this piece of information comes from Victoria Belinfilova's specific raw material training.
Precisely. And that's essential for the model's internal reasoning. If it gets conflicting information later, the roster lets it prioritize the input from the highest verifiable authority. It's an input for its own judgment process.
Okay, so moving to section 2, this is the actionable part. The structured knowledge and rules. These are the technical if-then heuristics that stop the model from making those naive assumptions.
Yeah, and what's fascinating here is how these rules force verifiable structure. They turn subjective ideas into objective checks.
Give me an example.
Okay, take the accord first rule for a category like sheepers. The rule mandates that the model must verify the structural scaffold bergamot, oak moss, and labdanum.
The classic structure.
A classic structure. If that isn't verified, it can't just call it a sheeper. It has to label it an interpretation, like a modern sheepery-style composition. It turns a historical category into a structural verification step.
That's incredibly specific. I also love this concept of concentration realism.
That comes straight from Mark Benka, the chemist. The rule is simple. You can't just up the oil content to make a scent last longer. Because increasing concentration, especially with fresh things like citrus, can actually distort the entire scent. So when a user asks for, a beast mode fresh citrus, the rule forces the model to look for structural alternatives like diffusive musks, instead of just naively suggesting a stronger concentration.
And to really calibrate these high-noise terms, you include hard verification markers. Why is one tiny fact like the 1% aldehyde dose in Chanel No. 5 so important?
Because that one number is a quantitative anchor. Without it, aldehydic just means soapy. With it, the model is calibrated to understand that the term refers to a prominent structural dose. It sets a baseline.
That makes perfect sense. So you've got the hard rules, the authority,
Yeah.
but how does the LLM know how to use all this? That's section 3, right? The narrative user guide.
That's it. This section is basically the instruction manual for the LLM's own brain. It converts the rules into instructional text, defining the role and the flow of the information. Its main job is to establish hierarchy. For example, it clarifies the difference between a marketing note, which is often just promotional language, and a technical accord, which is the engineered structure. And it tells the model it must always prioritize the technical definition.
Got it. And the final section is the control mechanism, the comprehensive industry glossary. This is just pure nomenclature control.
It's absolutely vital. It prevents the model from drifting back into generic, vibe-based definitions. It defines those complex terms that are critical for professional reasoning.
Like sillage, the trail a fragrance leaves behind.
Or fixation, which is the capacity of the scent to hold together as it evaporates.
And most importantly, you said it defines structure itself.
Right. The engineered architecture, the role of the materials, including the synthetic bones that often completely contradict the simple marketing pyramid of notes. We're defining the technical reality against the marketing story.
Okay, so let's see how this all comes together. How does this rigid system handle the biggest failure of all for an LLM, ambiguity? This is where you deploy these ambiguity shields.
Ambiguity shields are explicit rules. Their only job is to stop the model from guessing, to force it to ask a clarifying question when a high-noise term comes up.
And the classic example is out.
The classic example, a user just says, "I like out."
And the system stops. The out disambiguation rule kicks in.
The rule mandates a choice based on production reality. It has to ask, does the user mean a natural material, which varies wildly by species, region, distillation, or do they mean a constructed out accord, which is usually synthetic?
So it has to ask a follow-up.
A mandatory follow-up. Are you looking for a medicinal, smoky, or animalic style, or a constructed accord? It immediately elevates the conversation from consumer chat to a professional query.
And ensures the search uses the right parameters.
Which leads us to the final mechanism of ActiveRAG, the cognitive nexus. This is step 3, and its job is to force the model to verify and rectify its own initial chain of thought against all these anchors and rules before it generates the final answer.
So it's a final quality control check. It can't just spit out a plausible-sounding answer from its general training. It has to check its logic against the expert consensus.
Precisely. This is what we call cognitive alignment. For instance, it implements the natural versus synthetic neutrality rule, making sure the system treats synthetics as legitimate structural tools, not just cheap fillers. This final check ensures the system delivers justified, evidence-based hypotheses.
It moves past guessing and into real structural deduction.
And with that, the system is now fully epistemically anchored. It's ready for its next deployment phase. This whole thing is the setup for phase 2, logical reasoning.
This is where the real expertise starts to show.
That's right. Phase 2 introduces what we call the logician agent. This agent takes all these explicit, expert-elicited rules and starts applying them deductively to complex, real-world scenarios.
Like what kind of scenarios?
Like diagnosing the exact structural reason a vintage perfume smells different now, or recommending a structural replacement for an ingredient that's been banned by regulators. This is where the machine starts to demonstrate true expert-level reasoning.
It's such a fundamental shift. We've gone from information retrieval to actual engineered knowledge construction. And there's one last sort of provocative idea in all this that I think knowledge architects really need to think about. The integrity of this entire system required that natural versus synthetic neutrality rule. The AI is mandated not to rank perfumes based on natural content alone. It has to treat synthetics as legitimate architectural tools because that's the industry reality.
It's the truth layer.
It's the truth layer. So if the AI's core truth forces it to contradict what many consumers believe, this fetishization of natural ingredients, what does that tell you about the future of specialized recommendation? What happens when the truth that the AI is built on contradicts the language of the market? That's something for you to mull over as you think about building your own next-gen expert system.